up in between. Domain and range of a function. Domain and range of a function. Right, domain and range of a function. Right. Before I discuss this, I'm going to go through everything from the beginning. You can take the opportunity to learn everything from the start. If I write this, y is equal to fx is equal to x squared plus x plus 1, what would be the independent variable here and what would be the dependent variable here? So, independent variable. What is the independent variable? Can you see the board? You can't come here. What is the independent variable? X. What is the dependent variable? Dependent variable can be y or fx. Because y is equal to fx. They are equal to each other. Right? Next thing, what is the definition of y over fx? What is the definition of the function? That is what I'm asking. What is the definition of the function? Yes. The definition of the function is this guy. Right? Definition of the function is that. All good. Next question. See, look at how we are learning. Next. Who is responsible for a shape of a function? Who is responsible for the shape of the function? Who is responsible for the shape of the function? Answer? X squared. X squared. Definition of the function. Definition of the function. Definition of the function. Slowly write it down. I will help you as much as I can. But when you ask me a question, can I have another session? Help me. Then I am so afraid to say no. You understand my point? Yeah. Right. So, who's responsible for this? So you wrote it. Then, when you sketch or plot, your plot in Cartesian looks like this. Independent variable versus dependent variable. Agree? So, there are many versions you can make according to this question. Example. One can make this as x versus y. One can make this as x versus fx. One can make this as x versus x squared plus x plus 1. Do you understand? Doesn't matter how you define your y-axis, it's the same. Do you see that? It's the same, why? Very good. Right? I have seen, even here 10, 11 students, when I ask the difference between these two, they think they are different. Because they don't have the thinking to the right. So you guys don't have that problem. Okay? So this is fine. Now, when you plot it something like this, you can see that if you take one coordinate here, that coordinate is xy, right? Yeah, that coordinate is xy, right? Now listen to me very carefully. This xy coordinate is changing when it comes to here, right? So there can be p and q. Correct? That means along this curve, x and y both are changing, right? Is it very clear? So, according to this description, x is changing. According to this description, y is changing. So x is changing. When x is changing, there should be a boundary, right? Yeah. So, for example, I'm so hungry. Yeah. I need biryani. Right? There should be a boundary, right? I can't see the whole world, right? Yeah, one plate of biryani, half of a plate of biryani. So I should have a limit, right? So x is changing, should have a limit. Should have a limit. This limit is called domain. This x limit is called domain. Isn't it easy? Isn't it easy? Some easy things. Yeah. So similarly, y should have a limit. Y should have a limit. So this y limit is called, this y limit is called range. Is it very clear? Right. Put math into your common sense pocket. Can do magic with math. I'm going to give you an example now. The example is this. Think about y is equal to x plus 1. Next one, y is equal to x squared. What is this guy? Definition. What is this guy? Definition. X squared itself a definition. So, I'm going to plot it. When I plot it, this looks like this. 1. When I plot this looks like this is a parabola. Right? Now we need to find the domain and the range of these two. We do that first. Find the domain and the range. Do that first. Now, we are going to talk about the, look at this, very easy to figure out. Domain, right? Domain means, x limit. Look at this x. Forget about y. Then, what about this x? Forget about y. What about this x? Forget about y. Can you see from here, x is increasing? When it's going this way, x is increasing, yeah? X is increasing to where? Infinity. Because this curve is going to increase. Right? Here. X, 0. It is going down, yeah? So this x is decreasing, right? You can see x is decreasing. X is this coordinate, right? X is this coordinate. So when you take this point, and that is this coordinate, right? So that is x, 0, 0. So when you are going down, x is decreasing. You can see this is -1, for example, -2 example. So when it goes down, x is decreasing, right? X is decreasing to where? Infinity. Right? So we say x is less than infinity, greater than minus infinity. This is the domain. Domain is a limit, has a range. Is it very clear? Yeah. So what about the range now? Think about this. Here range, I would say y, right? Here y1, right? Here y2, right? So what is happening to y in this case? Again increasing, yeah? What about here? Y is again decreasing, yeah? So y also minus infinity. And that is your range. I did the first one for you. I did the first one. Do the same for the second one.
For the range, it's 0 or 1.
Yeah, so the answer, yes. Answer, look at the answer. Domain is x less than infinity, greater than minus infinity. Range should be less than infinity, greater than 0, greater than or equal to 0. Y equal, this curve is going to touch 0. Got it? Huh? Y. This is 1, yes. So that is the domain and the range, right? Yes. Huh? Greater than -1 here? No, it's because if you think about y, this is the lowest point, right? 0, 0. See, y also 0. So this 0 is at that point. So that's the lowest y value. Good. Okay, next part. Domain restriction, right now. Next topic, domain restriction. Domain restriction. Domain restriction. Common sense. What do you mean by restriction? Restriction means restriction. Right? Why you restrict? My kid is playing games forever. Infinite time my kid is playing. Right? So dad is going to restrict that for 1 hour. Yeah. Similarly, the domain can be restricted. This is how it works. Example. Y is equal to x plus 1. It is this, and the domain is this. Right? Domain is that. Now we are going to restrict the domain. This is how we restrict the domain. We are going to say y is equal to x plus 1, comma. We are going to say x is greater than or equal to 0. So we have to state somewhere about that restriction, right? So that we do right after the definition of the function. We are going to say, we are going to state that. This is our restriction. This is our restriction. Okay, so this is called domain restriction. The reason is domain means x. Correct? So if that happens, what you do, you just draw that like this only. See? Starting from x is equal to 0, right?
What about the other side?
What about the other side?
Right.
So it is not there. Other side is not there. We restrict the domain. Is it clear to you? Huh? So domain restricted, right? So I see there is a range also, right? Is there a thing called range restriction? What do you think? Yes? Actually not. Reason? Range is altered automatically with x. Why? Because y is the dependent variable. Yeah. We change only x. So that's why we call it independent variable. So whatever the restrictions, we do for x, not y. So there is no point discussing about y because y is dependent on x, right? So we have domain restriction only. So we never talk about range restriction because of that thing. Okay. So now we understand what is the domain, what is the range. Next page. Suppose you have, example again. Suppose you have f of x is equal to x squared plus 2x. Suppose you have fx is equal to x squared plus 2x. Can I write y is equal to fx is equal to x squared plus 2x? Can I write it this way? Can I put y? Yes, you can. Next. Can I write the same thing in this way? Y is equal to fp x squared plus 2x. Can you write this? No. You can't write it this way. You know the reason now. Can I write this? Y is equal to fp. You have p squared plus 2p. Can I do that?
Yes.
Yes, you can do that. Yeah? So, can I do this? y is equal to f of f of cat squared plus 2 cat.
Yes.
Yes, right? Okay, that is so stupid example, right? Can I do this? Y is equal to f, then you have that square plus that 2 times that, right?
Yes.
Right? This is the structure, right? So inside can be anything, yeah? Can I do this?
Yes.
Huh? So we are sort of going out of the, thing here. Can I do that? Yes. You can see pattern flows, yeah? Yes. You can do that. You can see the pattern. Now, what is f here? Function. Name of the function. What is g here? Name of another function. Name of another function. When you look at this, what is this? Function in a function. Right? Like a pregnant mother. Right? Yeah. Human inside human. Yeah? So this is called function inside the function. So in math, there is a nice word to this. What can be that? Yeah? Pregnant mother. The word would be composite functions. Composite functions. You get that? So now, when you see somewhere that you have to understand why I am doing these things slowly, I need to bring out a couple of 50s in from the class. That investment I'm doing here, right? I'm not just joking here. It's just spending 1.5 hours. It's not my goal. My goal is in 4 years' time, couple of 50s, couple of heads I should see from the class. Right? That way only I can give justice to you, eh? To understand. Okay, composite function. Let's think about this now. Now you have to use your brain, okay? Use your brain. So give you a question. Right? fx is equal to x squared plus 2x. gx is equal to 2x plus 1. Right? Question. What is f of gx? Second question. What is g of x? I'll give you 2 minutes. Nice. Look. F of gx, right? So, this is how you think. When you have x here, you have x and x next. Yeah? When you have p here, p goes here, p goes there. When you have gx here, agree? You replace x by gx, that's it. Now what is gx? 2x plus 1. So, that's it. Set me. Set me up. Is that right? Simple. This one? This one? G of fx. So that means x is replaced by fx. So it's going to be 2 fx plus 1. This is going to be 2. What is fx? X squared plus? Yeah.